Hey everyone, in the last video we have discussed about what is BST, means binary search tree, what are the properties of binary search tree and what are the advantages of binary search tree and what are the difference between binary search tree and binary tree. In this video we'll talk about that, how we can insert any value in a binary search tree. Let's start. So for inserting any values in a binary search tree, we have to follow some properties. So what are those? At first we have to allocate a memory. So how we can allocate a memory, I have already discussed about that, how we can create a node of a binary tree. You just click on the I button and watch this video. So at first we have to allocate the memory for a binary search tree. Then we have to check that a tree is null or not. So if a tree is null, it means we don't have any value within a tree. If null, then we'll add the data to the head node. So let's say that we don't have any value within the tree. We'll insert one value. We'll just set that value within our head node or root node, whatever you can call. Else if the item is less than root, then we'll perform the operations recursively for the left node. So we'll perform the recursive operation for inserting any values within a BST. Else we'll perform the operations recursively for the right node. It means if the data is greater than the root node, then we'll perform the operation for the right node. In this case, let's say that data is less than root data. So then we'll follow this property. Else if data is greater than root data, we'll follow this property. So these are the properties that we have to follow for inserting any value within a BST. Now we'll see that how we can insert any value within a BST. So you can see that there are some values. We will insert these values in a BST and we'll construct a binary search tree. So at first what do we have? We have 20. So you just pause this video and write in the comment section that where we'll insert this 20, at the left or at the right. So we'll insert this 20 at the left because 20 is less than 40. Now you again pause this video and write in the comment section that where we'll insert this value, that is 60. So you can do one thing, you just pause this video and write, let's say that 20 left, 60 right, or whatever. You just pause this. If you know the answer, you just pause this video and write your answer like this, that 20 will go to left, 60 will go to right, and where 30 will go, where 50 will go, and where 70, 10 will go. If your answer is right, you will get a heart from our channel. So 60 is greater than 40, so it means 60 will go to the right. Now where 30 will go? So at first we have to check that 30 is less than 40, so it will go to the left of 40. So 30 will come here. Now we'll compare this 30 with 20. So 30 is greater than 20, so it means it will go to the right of 20. So we can see that we have inserted 30 at the right of 20. Now where this 50 will go? At first we'll check with 40, 50 is greater than 40. Then we'll come here, then we'll check that 50 is greater than 60 or not. 50 is less than 60. Now we'll go at the left of 60. So you can see that we have inserted 50 at the left of 60. Now we'll insert 70. Why 70 will go? 70 is greater than 40, 70 is greater than 60. So 70 will go at the right of 60. At first it will go at the right of 40, then it will go at the right of 60. Now at last 10. So where 10 will go? 10 will go at the left of 40, then it will come here, then it will go at the left of 20. So you can see that we have inserted 10 at the left of 20 because 10 is less than 20 and also less than 40. So if you verify this tree, we can say that it's a perfect BST or binary search tree. So I think this portion is clear. If you have any doubt, just write in the comment section. Now we'll see that how we can implement this thing in code. So at first what we have to do, we have to declare a structure then we'll take two pointers, that is left and right, and then we'll take the data. So I have already discussed about these things in my earlier video. If you don't know how to create a node, just click on the I button and watch this video. Then what we have to do, we have to allocate the memory using malloc. So why we are allocating the memory using malloc? Because we are allocating the memory dynamically. That's why we are using malloc, and we'll get this malloc from the stdlib library. So we'll discuss that when we'll perform the hands-on. Now we'll see that what will be the code. So it's a recursive process. So we'll pass these two things in the parameter. So this is the node and this is the address of the head node or the root node. So at first we'll check that our tree is null or not. So it's a recursive process. So for every subtree we have to maintain the same thing. So if our head is null, if our h is null, then we'll simply put our temp into h. Else if temp data is greater than the data of a tree, then what we'll do, we'll again call this function with the right subtree of that node, and whatever value we have inserted, we'll return that at the right subtree of that particular node. And what will be the else if condition? It means a data is less than a node. So what we'll do, we'll simply call the left subtree. We'll simply pass the left subtree and the temp in the function. So whatever value it will return, it will store at the left subtree of that node. So at last what we'll do, we'll simply return the h. So whatever it will return, it will be stored over here or it will be stored over here. So you can see that we haven't put any condition for equals to case. For the equals to portion, it will also return the value. So whatever value will return, it will be stored over here or here. And at last we'll return the entire tree to the root node. So now we'll take some value and we'll see that how we are performing this thing. 10, 20, 5, let's take some random value, 40. So at first our h is null. So our root is null, so we are passing h here and we are also passing the temp. So at first within temp what we have 10. Now our head is null, it will simply assign 10 here. It will simply assign 10 here and it will return the h. So it means whenever we are calling the insert function at the first time, then it will simply add the value at h and it will return the value. So currently in root or h we have 10. Let's say h. Now we'll add 20. So at first 20 will come here. So it's a recursive function, that's why we'll use stack. ins. At first we'll call this ins function. So let me write like this, and insert. So at first we'll pass what? We'll pass, let's say that 20, and we'll pass the h. So it will come here. So our h is not null. Then what it will do? It will come here. Now temp data is greater than h data or not. At first at h what we have? We have 10. So our 20 is greater than 10. So it means it will call the insert function and it will pass the right subtree of that node. So what we have at the right of 10, so initially it's null, right? So we'll simply pass this null, let's say that 20 and null. So again when we'll come in this function, then we'll see that our h is null because we have passed null, right? So now we'll see that h is equals to null. It means we'll simply assign temp into h. So it means we'll assign h equals to temp. Within the temp what we have 20. So it will be temp, let's say the address of temp is fx whatever. So we'll simply assign that and we will return h. So these conditions won't be executed. We'll return h. So where this h will receive? The h will receive at the h right. So you can see that h right equals to, we can say that whatever value we have inserted, it will be added at the h right. So now what we have at the 10th right, we have 20. So this is how we can insert any value within a binary search tree. So after adding this value, we'll simply return age and it will be returned to the root node. So why I'm saying that it will be returned to the root node, in my hands-on video I'll discuss about that. So at last we are returning the final constructed BST and we'll receive that here. So from where we, let's say that root equals to insert, we have called this function. So whatever tree that we have constructed, it will be stored in the root. Now we'll perform the same thing for 5. So what we'll pass? So within temp, what we are passing? We are passing 5. So here we are passing the address. For your simplicity, I am just writing 5. So we cannot pass any data here because we are passing the pointer, right? Now here what we are passing? We are passing age. So within age, what we have? We have 10. Now at first we'll see that age is null or not. Age is not null. Now what is the age data? That is 10, right? So at first we'll check that 5 is greater than 10. So 5 is not greater than 10. It means this portion won't be executed. Now we'll come here, then we'll see that 5 is less than 10. Yeah, 5 is less than 10. So it means we'll again call the left subtree in a recursive manner. Previously we have called that for the right subtree. Now, so we'll simply pass in temp, what is the value of 10? That is 5, and within age left, what do we have? We have null. So we'll simply pass null over here. So here we are passing the pointer, not the data. So I have just written this 10 for your simplicity. So you can see that we are passing null over here. So we are passing null over here. H is equals to null. Then we'll assign temp within the age. What is the value of temp? The value of temp is 5. We'll assign 5. Then these conditions won't be executed. Then we'll simply return age. So age will be returned here. And where it will be stored? It will be stored at the age left. It will be stored at the age left. So here we are getting the updated tree and we are storing that at the left of age. So you can see that we are storing 5 over here. So x means null. So this is how we can add any values within a BST by maintaining its properties. So I think this portion is clear. Now we'll look at the hands-on. So I know it's being a long video. If you are enjoying this video, just hit the like button. So as you can see in my screen that we have imported the libraries. We don't need the Conio H here. Yeah. So we are importing the libraries. Then we have added the structure that we have declared the structure. This is the create node function. Here we are taking the data and we are setting left and right as null. Then we are setting root equals to null. So at first when we call this insert function, at first we are checking that if our head equals to null. So it's a recursive process. For every insertion we'll check the same thing. So when we'll get the h equals to null, I have already discussed about this thing. If our h equals to null, we'll simply insert the data. Else what we'll do, we will just call the right subtree because temp data is greater than age data. So whatever data we are inserting, it's greater than the root node. Else what we'll do, we'll simply call the left subtree. So you can see that within the main function, I have created a switch case. So within that, in the case 1, we are inserting some data, and at the case 0, we are traversing the tree. So I have an entire playlist for the tree traversal. If you don't know that how to traverse a tree, just click on the I button and watch this video at first. So for the BST, I'll create separate video for the traversal. So we can see that if we go for the case 1, it means we are inserting the value. So whatever value we are inserting, it's returning the final constructed tree in the root node. And we are passing the age as the reference pointer. So you can see that we are passing the age as the reference pointer. And here we are receiving the finally constructed binary search tree. Now we'll compile this code and we'll see that what are the values that we are getting. Let's say that insert. At first we'll call insert function. Let's say we'll insert 10. Then we'll insert 20. Then we'll insert 5. Now we'll go for the traversal. So we can see that 5 is at the left of 10. So in order traversal, whatever value we are printing, it will be in a sorted manner, because at first we'll print the left subtree, then we'll print the root node, and at last we'll print the right subtree. So you can see that within the in-order traversal, we are printing the entire tree, and we are printing the tree for the pre-order and post-order traversal as well. So this is how we can insert any value within a BST. If you have any doubt, just write in the comment section. See you in the next video.